All right, let's dive right into this explainer. We talk a ton about AI generating basic code snippets, just spitting out functions. But today we're looking under the hood at the exact training data that teaches an AI to map out a massive software project before it writes a single line of code. We are breaking down this totally fascinating curriculum that trains AI models to think, not just like a junior dev trying to get something to compile, but like a high-level software architect designing a scalable system. It's a total game changer.
I mean, we've all been there, right? You hit that dreaded infinite loop in a React app. Your browser completely freezes up, and suddenly your CPU fan sounds like an absolute jet engine taking off. It's the worst. But when you ask an AI to fix it, it doesn't just guess, it relies entirely on its training. So we're going to explore the exact blueprint that transforms a blank slate AI into a seasoned tech lead, one that can systematically untangle your worst real-world developer nightmares.
Section 1. Meet Vibe-Coding-Instruct, the curriculum of an AI.
So to really wrap our heads around this curriculum, we're looking at a specific dataset from Hugging Face called Vibe-Coding-Instruct. Now think of this not just as a bunch of loose text files, but as a highly specialized, rigorous training manual. And to grasp the sheer scale of it, look at the row count. We're talking exactly 1.1 million meticulously structured rows of data. That's 1.1 million distinct repetitions of complex problems paired with comprehensive solutions. Just like we build muscle memory through grueling practice, an AI internalizes logic through this massive, structured repetition.
And here's the wild part. It clocks in at just 459 megabytes. Now, you might be thinking, wait, that's not terabytes of data. But guys, that is exactly the point. This isn't some messy, chaotic scrape of the entire internet or random Reddit threads. It is densely packed, pure signal. Every single kilobyte is highly focused on specific scenarios designed to strip away the noise. It literally takes an AI from a basic syntax engine to a highly effective senior tech lead. It just goes to show, when training high-level reasoning, quality and structure completely beat sheer volume.
Section 2. Anatomy of the data, instruction versus response.
The real magic here isn't just what is being said, but the strict formatting rules. It's a macro to microstructure that perfectly mirrors real-world development. Check this out. The AI gets short, punchy instructions, usually just 35 to 89 characters, something super vague like, design a scalable SaaS. But it is forced to deliver a response between 170 and 337 characters. It's intentionally demanding the AI take your tiny, vague request, the classic one-sentence Jira ticket we all love to hate, and explode it into a methodical, structured architectural plan. It's doing the heavy lifting of project management for you.
Moving on to Section 3. Real developer scenarios, the daily grind.
Honestly, scrolling through these instructions reads like a laundry list of a developer's daily headaches. This dataset doesn't waste time on Hello World or reversing a string. Nope, it drops the AI straight into the deep end. Fixing 500 errors on an API, containerizing scalable SaaS apps, deploying full MERN stacks. These are the exact high-stakes fires that engineers put out every single day. The training hammers home that the model's job isn't just writing an isolated script, it's architecting entire end-to-end platforms.
Which brings us to Section 4, the architect's blueprint and forcing the vibe.
So how does it pull this off? Well, it relies on a super rigid formula. The AI can't just start rambling or throwing out random libraries. Listen to this quote, pulled straight from the responses. Include milestones, technology choices, risks, testing strategy, and scaling considerations. Almost every single response in those 1.1 million rows ends with that exact mantra. Imagine reading that hundreds of thousands of times. The AI is literally having the comprehensive, cautious mindset of a senior project manager permanently wired into its neural weights.
Section 5. Step-by-step plans, solving the problems. Let's see this blueprint in action. Say the AI gets a short instruction like, deploy an AI application. The curriculum forces it through these macro-level steps. First, containerize the services, because any senior dev knows portability is absolutely key. Second, configure GPUs if needed, anticipating the actual hardware. Third, add logging, metrics, and auto-scaling, because let's face it, code you can't monitor is just a massive liability. It defines the long-term strategy and then naturally finishes with those milestones and scaling considerations so things don't fall apart on day 2.
All right, Section 6, Building AI with AI, the local LLM plan. This part is incredibly meta. The dataset actually gives the AI a strict curriculum on how to build and integrate other AI models. It is literally an AI learning to architect future AI systems.
For local LLMs, it mandates planning around precise tech like Ollama or llama.cpp. It explicitly tells the model, hey, manage those context windows so memory doesn't overload and optimize inference performance so the user isn't stuck waiting forever. It ensures the AI is completely up to date with modern machine learning best practices.
Section 7. The end results. Training the next assistant.
So let's step back for a second. What's the ultimate goal here? By grinding through this pattern 1.1 million times, the AI doesn't just memorize syntax. I mean, anyone can look up syntax on Stack Overflow, right? Instead, it internalizes the overarching vibe and structure of professional software architecture. It learns that coding isn't just typing real fast. It's mitigating risks before they explode, picking the right tech stack, and planning for scale so your servers don't completely melt down when you get your first 1,000 users. And if we look at the underlying dataset metrics, you can see this strict character bounding is incredibly intentional. Short inputs, highly focused outputs. There is zero room for fluff. No hallucinations, no endless tangents, just pure actionable project management. By trapping the outputs in that 17 to 337 character range, the AI is trained to deliver high-impact insights super quickly, basically acting exactly like that highly efficient engineering manager you'd kill to have on your team. Which brings us to our ultimate takeaway for this explainer. We've got models now that are trained on over 1 million exact architectural blueprints, not just mere code generation. So it leaves us with a really provocative question to think about. If the AI is getting this good at architecting the infrastructure, anticipating the risks, and setting the precise project milestones, is the future of development less about typing out individual lines of code and more about just managing the vibe? Thanks for hanging out with me for this explainer, and I'll catch you next time.